Hello and welcome to Chapter 8, Lesson 1. This is on function tables, and the entire concept for this entire section is based on the relationships. And so you want to keep that in mind as we go through this section. So as you take a look here on textbook page 579, that's where we're at. All right, so if you look here at example number 1, let me just go ahead and make this a box for you so that you know exactly which one we're talking about. It says that a ruby-throated hummingbird beats its wings about 52 beats per second. And then it says to make a table showing to show how many times the bird beats its wings in 2 seconds. All right, so if you look here at number 1, it says to make a table, but it already has the table set up for you. So it says the number of seconds they're asking about is the 2 seconds. So that is right here. If you notice the 2 seconds right there. And they're asking you to use the function rule, which is up here. It's about 52 beats per second. So that's how they got S times 52. S times 52 was their problem. And they want to know when S is 2, so 2 times 52. So this is an S. Actually, okay, so the original problem is S times 52, which we got from right here. Okay, and then they just want you to substitute this 2 because they're saying how many beats does it beat in 2 seconds. So we put the 2 in right here, as you can see, and then they want you to do the multiplication, obviously, so that you can go ahead and work that out. So you can work that out to the side. 52 times 2. And so you should get 104. Okay, go on to the next one. The next one, they want you to fill in this piece right here. So the first thing you need to look at is, again, the original problem is S times 52 still. So then to fill in this portion right here, you're just going to simply plug in the 6 from right here to the S's spot. So let's go ahead and erase that. All right, so on your paper, what it should look like is 6.52. So again, you'll be starting with S times 52, as you were. Then we're going to substitute the 6. So it'll be 6 times 52. Then you'll do the multiplication out to the side. And then you're going to go ahead and get your answer, which is 312. So as you can see, you want to do the work. The multiplication should be out to the side, and then this S times 52 or 6 times 52, so this right here, whoops, this piece right here should go in right here, okay? And then your final answer here will go in over here. So let's go ahead and go on to a new page so we can do the last 2. Okay, so now we're looking at still textbook page 579, and it says to make a table to show how many times it beats its wings in 20 seconds. So they want you to fill in the entire table. So remember, the 20 seconds, which is right here, is going to go in the number of seconds. So let's go ahead and fill that 20 seconds in there. And then we're going to substitute this 20 that we just erased. We're going to substitute the 20 for the S right here. So we're going to go ahead and reveal the equation, which is 20 times 52. Then off to the side, you should be doing the math for 52 times 20. I set it up this way just because it's easier for me. I can put the 0 out here and then just multiply. 2 times 2 is 4, 5 times 2 is 10, and I get 1,040. So that is your final answer there. If you look at number 4, you're going to do the exact same thing, but you have to read the problem. Be sure that you read each problem. It says a giant hummingbird beats its wings about 10 times per second. So they've changed it. It's no longer this S times 52. This is now going to be S times 10, okay? It says to make a table to show how many times a giant hummingbird beats its wings in 3 seconds. Okay, so the number of seconds, which is right here, we're going to go ahead and put that in as 3 because it said 3 seconds right there. And then for the S times 10, now we're going to substitute 3 for that S. So let's go ahead and reveal that. So it should be 3 times 10, and then 3 times 10 we should be able to do on our head, which is 30. All right, so here we are in textbook page 580. So you want to make sure that you get to textbook page 580. This textbook page is going to be very important because number one, there's a lot of key vocabulary on this page. And while this vocabulary won't make sense at first, because it really kind of doesn't until you start to use it, you do want to make sure that you come back and study this. You want to put a big star on this page because this is where you're going to study for the vocabulary portion of your test to make sure that you know exactly what that vocabulary is. So let's go ahead and put study there. Ooh, that's not pretty. All right, so it says a function rule. I'm going to get my little highlighter here, but I'm going to change the color. There we go. A function is a relationship, is a relation that assigns exactly one output value to one input value. So what they mean by that is something like when x is equal to 2, y is equal to 7. So you get one of these and one of these. It's not going to be a set. Like when we go further into the chapter, you're going to see that you can have several different answers for an inequality. This one has a very specific answer. When x is something, y is something else. So it says the number of wings or beats, which is the output. So the number, which is the output, depends, that word depends is very important, on the number of seconds, which is the input. So the function rule describes the relationship between each input and output. So remember at the beginning of this chapter, I said that it's all about relationships in this chapter. You can organize the input-output values and the function rules in a function table. So the function table is just a way of organizing the function. In a function, the input value is also known as the independent variable. Now, this is not the first time you should see independent variable. You should have already seen it in science several times by now. But the independent variable, you always want to think about your parents are independent and you're dependent on them. So the independent variable doesn't need anything else. You don't need anything else to figure out what the independent variable is. That's actually the input value. So it can be any number you want it to be, which is what it says here, since it can be any number you choose. And then let's go ahead with that color. Then it says the value of the output depends on the input value. So the output value is known as the dependent variable because what you get for your answer is going to depend on what you put in for x. You want to think of it sort of in terms of equations for that specific section. All right, so let's go ahead and take a look here at example 1. It says the output is 7 more than the input. Now, you don't want to just skip past the wording here and go directly to the table because the tables are pretty easy to fill out once you get used to them. You want to make sure that you're paying attention to this wording. The wording right here is very important because there are going to be times, just like when we had to write equations and we had to write expressions, there will be times when you have to set up the table based on this sentence, which says the output is 7 more than the input. So just really quick, a reminder, remember 7 more than the input means 7 more than, less than, greater than, or fewer than, which is why they switched the order here. Remember that from your last test. So, and since you don't know what the input is yet, technically, that's what they call x. So it says complete a function table for the relation. So the important, very, very, very important information here too, is they say that the function rule, so let me go ahead and erase this. They say that the function rule is x plus 7. So that's what goes right here. That's the problem. That's the equation. But they call it the function rule. To get the answer, you're going to add 7 to each input. Okay? So now they've given you the input in this problem. And notice they've also given you, they told you that the input is x. Okay? So then see where it says x here is 10, right here. Whoops. So that means right in this spot, let me see if I can get it in there. 10 plus 7, that goes in there. And then your output is going to be 17. So basically what this table is telling us, with this function rule, x plus 7, when the input is 10, the output is 17. So there's the relationship. The next one says 12. So it'll be 12 plus 7, which is 19, and 14 plus 7, whoops, there we go, which is 21. So again, for this one, when x is 12, or when the input is 12, the output is 19. When the input is 14, the output is 21. So this is the relationship. And again, just a reminder, this is one input value for every one output value. That's very, very important. All right, still on the same page, example 2 says the output is 5 times the input. So remember from our last equation section, if you were just trying to write this and you weren't looking at the table that they gave you, the output is 5 times the input. That would give you the 5x. and this 5x is what goes in for the function rule. So now they put the function rule in as 5x, and then they give you the values of 8, 10, and 12. So what you need to now do is plug in the information for 8, 10, and 12. So let's go ahead and do that. So we have 5 times 8 needs to go right here because x is equal to 8, and so the output would be 40. Then it will be 5 times 10, and the output is 50, and it will be 5 times 12, and the output is 60. So again, I want you to pay very close attention to the way that I'm saying this because I'm speaking about the relationship, and I'm saying when the input is 8, the output is 40. When the input is 10, the output is 50, and when the input is 12, the output is 60. Again, this reinforces that you have one answer, or I'm sorry, you have one number for every other number in the function. There's exactly one. All right, you want to go ahead and pause the video now so that you can try the do these problems to find out for A and B. So go ahead and try these on your own now. All right, welcome back. Let's go ahead and take a look and see what you got. The first thing when you're looking at these tables is you want to make sure that you identify the function rule. And so for the first one, A, the function rule is x minus 4, and for B, the function rule is 3x. So that's essentially, that's the equation or the problem. So it's not technically an equation in here because it's not set up as an equation, but I'm saying that's where you're going to look for what is the problem, how do I work this out? So now you have x minus 4 here for A, and they say the input they want you to put in for x is 4. So all you're really doing here is substituting. So wherever you see x, you're going to put a 4. So on this first one, you should have 4 minus 4, and then the output would be 0. So now we're going to have the 7 here, because 7 is now for x minus 4, and that gives us the 3. Then here we'll have the 10 minus 4, and that will give us 6. So for each one of these, you would say when the input is 4, the output is 0. When the input is 7, the output is 3. When the input is 10, the output is 6. Let's go ahead and take a look at B. For B, the problem was 3x, or the function rule was 3x. You want to get used to using that vocabulary. So the function rule was 3x, so now we're going to substitute 0 for x. Now when I'm checking this on your homework, your assignments, your tests, your quizzes, it's very important that you keep the things in the order that they're supposed to be in. So for instance, on this first problem, if you put 0 times 3 here, you're not showing me that you're substituting into the function rule. So it really needs to be 3 times 0. Now the way that they have it written is fine, the 3 parentheses 0. I would also be fine with 3, let me see if I can. I would also be fine with 3.0. In fact, I would prefer it that way. The only thing that is not acceptable is 3, let me try and get a different color here for you. You cannot do 3x0 using that for multiplication. This is not an acceptable way to show me the function rule here. You just can't do it anymore because as you can tell, as we discussed in the expression section, x is now used as a variable. So you can no longer use it for multiplication. You can either use the parentheses or you can use the dot. So now when you multiply 3 times 0, you of course get your output of 0. And then we're going to do 3 times 2. And again, it's very important that the 3 comes first, the 2 comes second. And you'll get 6. And then the 3 times 5, and you get 15. So hopefully this is all kind of coming back to you. The bottom line for this specific piece here is that you've got the original problem, which you're used to seeing. So we have original. Then you substitute with the input. Substitute. And then you're going to solve to find the output. So you're solving for the output in this specific section. The original problem is the function rule. And you're going to be substituting the input for x. All right, so now we're on textbook page 581. Oh, that does not show up well. Let's go ahead and change that to a different color really quickly. All right, so now we're on 581, and it says the input and output of a function table can be represented as a set of ordered pairs. This is very important, okay? So now we're bringing ordered pairs into it. And remember that ordered pairs look like this. So, and this is the x value, this is the y value, okay? This is very, very important because functions basically just boil down to these ordered pairs, and then eventually you're going to be graphing them. So it's very, very important that you get this ordered pairs concept here. In this lesson, the x value represents the input and the y value represents the output. Okay, so this is the x value and this is the y value. And again, this is the function rule. All right, so let's go ahead and look at example 3. It says find the input for the function table. Use the backward strategy, or the work backward strategy. Sorry about that. All right, so use the work backward strategy to determine the input. If the output is found by multiplying by 3, then the input is found by dividing by 3. So basically, what you're looking at here, and you want to make sure that you're kind of following along here, because what you're looking at here is you're going to take this 3x, which is right here, and you're going to say when 3x is equal to 6, because remember the output is right here, what is x? So now when we're looking at it like this should sort of start to look like an equation to us. So now we're going to divide each side by 3, which is that inverse that they were talking about, and you get x equals 2. So now, so the 2 goes there, and then right here you would have the 3 times 2. All right, bear with me, I'm going to go to the next page to make it a little larger. All right, still on the same problem. So now we have, we said that x is equal to 2. So then we need 3 times 2 here. So that's how we're going to be working backwards. So let's look at this 15 that they gave us right here. So we know that 15 is our output, which is our answer essentially. And we know that our problem, I'm going to change colors for you so you can see, our problem is right there. That's the 3x. So see the 3x arrow, and then we've got the 15 input, which is, let's just change colors here so we can help you out. There we go. Ooh. Okay, so now hopefully you can see that 3x is equal to 15. So from here, you're just going to divide each side by 3, and you get x equals 5. So now that you know that x equals 5, you can put that right here, but don't forget to fill in this part right here where you use the function rule 3 times 5. And this is also sort of your check where you can do 3 times 5 equals 15. So you want to make sure that whatever you get in this block right here is equal to the 15 there. Let's go ahead and look at the very last one that they have here, and I'll use the color coding system again. Okay, so as you see here, we have the 21. See that 21 right here? That's how we're going to get what goes on this right side of our equation, okay? Then you also see here that we have okay, you can see here that we have our function rule, which is 3x, so that's how we get what goes on this side of the equation. Now we're just going to divide each side by 3, and we get x equals 7. So we're going to put 7 in here for the input, then we're going to do our 3 times 7, and again, a reminder, it's very important that this is in the correct order. 3 times 2, 3 times 5, 3 times 7. You can't do 2 times 3, 5 times 3, 7 times 3. None of these are acceptable because you need to be plugging it into this 3x. All right, so now you want to go ahead and pause the video so that you can try C and D on your own. All right, welcome back. Let's go ahead and take a look at C and D. All right, so the first thing I'm going to identify here is my function rule, which is 2x minus 1. So I'm going to go ahead and write 2x minus 1 because I know that goes on the left-hand side. Then the next thing I need to identify here is going to be my output, which is going to go on the right-hand side of the equal sign. So that's my output here. So for this first one, it's going to be 1. So 2x minus 1 equals 1. So now I'm going to use how I was solving equations in the last section to solve this. So now the first thing we're going to need to do is to add 1 to both sides. Get rid of that. 1 plus 1 is 2. Remember, this is a two-step equation, so it's essential that you rewrite the problem now. Now all you have left on this side is the 2x, because the minus 1 and plus 1 cancel each other out, equals, and now 1 plus 1 equals 2. So this is your new problem. So new problem. And I actually meant to mention on this page for these two problems, you're going to need an additional sheet of paper. So if you can pause that so that you can try and get that onto an additional sheet of paper, that would be great. All right, and now you're going to divide each side by 2, and you have x equals 1. So now we're going to go back up here and we're going to show that the input needed to be 1. Then the problem should be 2 times 1 minus 1 equals 1. Because all you did here was you substituted this 1 into this spot right here. Everything else in this equation up here, this function will stay the same. All right, continuing on, the next problem, it says we're going to be, of course, still having the 2x minus 1, which came from right here. And then our new output is going to be 3. So now when we have equals 3, which came from right here, we're going to go, okay, let's go ahead and solve for that. So we have plus 1, because that's the inverse of subtracting 1 from each side. You get 4 here. Now you have 2x equals 4. You're going to now divide each side by 2. And you have x equals 2. So up here, see that x equals 2. You want to show how you substituted this 2 right here into this 2 right here. All right, the next piece of that same problem, I'm going to go ahead and erase now so that I can show you the same thing on the next problem, but you don't need to erase. You need to still continue to write this on your additional sheet of paper that should be stapled into your textbook on page 581. You can fold it over so that it doesn't cover the whole page. All right, let's go ahead and look at this. So then the last piece we've got, again, still 2x minus 1, but now it's going to equal 5. So we're going to add 1 to both sides, as we've been doing. 5 plus 1 is 6. We get 2x equals 6. Divide each side by 2, and we get x equals 3. So now up here, we're going to go, okay, x is now equal to 3. Okay, and then we're just going to plug it in like we've done before. 2 times 3 minus 1. Okay, so let's go ahead and do the same thing for D now. For D, you're getting the function rule right here, 3x plus 2. Okay, and now for the first one, you're going to do 3x plus 2 equals 17. So now to first start to handle this, you're going to subtract 2 from each side, just like we've been doing. That's the inverse to get rid of that. 17 minus 2 is going to be 15. Then you're left with 3x equals 15. Then because this is a two-step problem, obviously you're going to want to make sure that you do that second step because you still need to find x. So divide by 3, and you get x equals 5. So up here you should have 5, and then you should have 3 times 5 plus 2 because this 5 right here comes from this 5 right here. All right, now this next one, we're still using the 3x plus 2. So we'll write that again, 3x plus 2. But now we're going to be looking at equals 20. See where we got this 20 from? Let's see if I can make that a little darker. So 20, whoa, that's a little too dark. Let's try that again. Okay, so now we're going to put that 20 in. That's where we got the 20 from, and that's where we got the 3x plus 2 from. So try and follow along with the colors. Then the next piece, we're going to go ahead and just solve the equation. So let's go ahead and subtract 2 from each side. That gets rid of that. Because remember, the goal is to isolate the x. So that's why we subtract 2 from each side. And remember, this is the boyfriend-girlfriend analogy, where the boyfriend and girlfriend want to break up. That's the 3 and the x, but they can't until the 2 is gone. So now you have to do 20 minus 2 is 18. So now your new problem is 3x equals 18. And from here, you're just going to divide each side by 3. And you get x equals 6. So up here on top, you should have x equals 6. 3 times 6 plus 2 equals 20. Okay, and I should be able to fit it off to the side here for that last piece. Again, just like all the others, we're going to start with the function rule, which is 3x plus 2 equals, and now we're going to be doing, I'm going to go ahead and erase this too so that it's not confusing for you. Now we're going to go ahead and do equals 29. So now we're going to write that 29 right there. All right, we're going to go ahead and proceed to solve the problem. Subtract 2 from each side. 29 minus 2 is 27. So now we have 3x equals 27. Then we're going to go ahead and finish the problem off. Divide each side by 3. And we get x equals 9. So you should have x equals 9 here. And then you have 3 times 9 plus 2. Again, the order is very, very, very important here. You cannot give me, so now I'm looking at this right here, you cannot give me 2 plus 3 times 9. That's not okay. You cannot give me 27 plus 2. That's not okay. it has to be a substitute situation. It needs to be substituted exactly as it is in the function rule. All right, looking at the bottom example, it says the Gomez family is traveling at a rate of 70 miles per hour. Okay, so that 70 miles per hour is indicated right here in our function rule. The function rule that represents a situation is 70x, where x is the number of hours. It's very important that you're paying attention to what it's saying. It says where x, whoops, way too much. Okay, make that a lot smaller. Where x is the number of hours. That is a super important thing to note. So x equals number of hours. Okay, make a table to find how many hours they have traveled at 140 miles. So again, this is where it gets tricky. You want to make sure that you're plugging the numbers into the right part of the table. So it says make sure to find the number. So you're not plugging this 140 in to the 70x. What they're giving you is the output. So they're saying make a table to find how many hours they've traveled at when they go 140 miles, 280 miles, and 350 miles. So they've given you the outputs, 140, 280, and 350. So in order to find those, you would be working backwards. So technically, these guys right here, and I'm just going to let you see, I mean, obviously, they're already in there for you, but these guys wouldn't be here. Okay? And nor would those guys. All right, so you would be given this empty table. You would have to write in the function rule, which would be right here. You would have to write in the outputs, which would be right here, and right here. And then you would have to solve using the method that we just used in the last example. Then it says the input and output values are ordered pairs. So let's go ahead and erase everything we've written on here now so that we can see those ordered pairs. So the ordered pairs that you got, we've got 2 and 140. So see how 2 and 140 is right there? Then we have 4 and 280, which is right here. And lastly, we have 5 and 350, which is right here. Now, obviously, the dot itself is right where the dot is, and that's where I'm looking for it to be. It's very specific. I was just circling it so that you could see that that's how they created the ordered pairs. Okay, you want to go ahead and turn to textbook page 582. So this is textbook 582, and you want to go ahead and look at problem, the got it problem. So go ahead and try and do this problem on your own, and pause the video and be right back. All right, so I went ahead and blacked out the function rule too, because on a lot of these it's going to say make a table. So on this one, for instance, it said right here, make a table to find how many hours. So they gave you the table already set up. It's really important that you know how to create the table as well. So you have the input or X on this side, you have the output or Y on the right, and then in the middle you want to have the function rule. Okay, so I'm going to erase those now though so that we can go ahead and color code as we go. All right, let's get started. It says Brianna bikes 12 miles per hour. A little too dark. Make it a little smaller. All right, 12 miles per hour. The function rule that represents this situation is 12x. So that is where this comes in. We would write 12x right there. Now again, obviously this is written for you and that's totally fine. You don't need to rewrite it, but I just want you to know that is the function rule. When you need to create your own table, that's how you'll do it. So then the next piece, if you wanted to, I'm going to go ahead and draw the function table again for you down here because I want you to see how you would create it on your own. So you'd start with the input, the output. Okay, so here we are. So again, that first thing, as soon as they told me that the function rule was 12x, I would know that that needed to go in the middle, okay? Then we can look at the input rule, or the input section, which is gonna be right here. So input, and that would be x. Now, as soon as we see that this 12x is all set up for us, we can go ahead and do, okay, 12 parenthesis, 12 parenthesis, 12 parenthesis, because we know that whatever we put in here for an input is going to go in these 3 parentheses. And then the last piece, which will be on the outside, is going to be the output. And that will be your Y value. All right, so the input values that they gave you, I'm going to color code those in green for us. It says, make a table to find out how many hours she has biked when she has gone 12, 36, and 48 miles. So you need to think about, she goes 12 miles per hour. Where am I going to put that 12, 36, and 48? Because the two options are this. They're either going to be your answers, which are here, the output values, or they're the input values. So you need to figure out which one it is. The way that you figure that out is, let's go ahead and look here. All right, so the way that you figure that out is you go, okay, it says the function blah, 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 where x is the number of hours. So x is the number of hours, and it says make a table to find out how many hours. So what that means is you're solving for this section here. So these numbers that they gave you, the 12, 36, and 48, they can't go, let's see. So the 12, 36, and 48, they cannot go in here because you're solving for here. So that means by order of elimination, or by process of elimination rather, that means that they have to go here. So it'll be 12, 36, and 48. So now that we have that in here, we can look and we can go, oh, okay, this is even pretty easy for us to actually do in our head. And you know how math teachers like that. So I can go, okay, 12 times what equals 12? Well, oh, that's 12 times 1. So 1 hour. 12 times 3 is 36. And 12 times 4 is 48. So the answers here are 1, 3, and 4. But then they want you to use them as ordered pairs to plot them on a graph. So that's our very last step. Very, very important for you to know how to do. So let's go ahead and do that. So our ordered pairs are going to be this. 1, 12. We got that from here and here. 3, 36, and 4, 48. Okay, we got those from here and here and here and here. So then we come over here to our graph and we plot those points right here, which is what you'll see. The 112, the 336, and the 448. All right, we're all set here. We're all wrapped up here. What I need you to do now for your assignment that will be due during our next class section is going to be on textbook page 582. And I need you to do numbers 1 and 2. And right now, while you're looking at it, I need you to go ahead and copy the answer for number 3. And also, when you finish, you want to rate yourself here. So when I'm coming into class, or when you come into class the next time, I'm going to be checking for your notes on all 3 of the pages. And then I'm also going to go ahead and check for these answers here. So you need to have all of the tables filled in. So this table, this graph, you need to have this copied, and then you need to have rated yourself. Good luck, and even if you don't know how to do it, you want to make sure that you go back through the notes and you line by line try and plug things in and do your very best. Remember, trying is better than not.